All right, thank you for attending this week's CBOM CycloneDX meeting. Um, last week, Nicholas, or last time we met, we had discussed enumeration of algorithm families, if I recall. Is that your recollection as well?
Yes, took me a while to find the mute button or the unmute button, but yes.
Yeah. Um, do we want to dive into that today and see how far we can get? Um, and just for clarity, this was going to be the algorithm family
Mhm.
was going to be an enumeration, right? Because there's only so many of them versus all the variants that's just infinitely going to be possible.
Yes, that was also my understanding. Actually, one note here, I actually had a look at the things that ScanOS open sourced, which is related to the SPDX efforts. I think there is something we could take from that because they have an enumeration of basically algorithm families, but we should be, I guess, careful and maybe with Barthel's knowledge figure out if that's actually a correct one.
Sure.
Yeah, so they try to do best effort. Let's put it that way. It doesn't look like they have a lot of expertise. Just they try to, if they see something in the wild, to add it. Basically,
Right,
that by their approach.
right, right, right.
How did they do that? Also, do they have a enumeration also kind of these algorithm
Kind of,
families?
but
Yeah.
like there's just not a lot of consistency. I don't think there was just a lot of care taken to create that enumeration list.
Yes.
Like Shaw, for example, is all lowercase with an X at the end to represent the different links that the hashing algorithm could theoretically have. Not the approach I would have taken. Um, I do think we discussed last time about and I think we made a decision on this, but let me just clarify. Um, we wanted to use the names of the algorithm families as they appear in either the standard for that or the research paper that actually defines that algorithm family, correct? So this brings up the requirement that these enumerations are going to be case sensitive. Is that do I have the correct understanding?
That was also my understanding.
Okay. That's less than ideal for me. I love consistency, but I understand why we need to do that. Okay. So do we want to use the ScanOS stuff as kind of a starting point just to kind of help us enumerate stuff?
Yeah, I think we have the two options to combine in the beginning. Let me. So in the Sonne plugin, we also did basically a group of algorithms based on the family, or try to. So we also IS, and for char we do have it as SHA, SHA-2, and SHA-3. So basically a little bit different, but I think that's more aligned how we would have it then
Yes.
in our enumeration list. So I think going through this list and having the other the scanners list as a starting point with a little bit more careful reading there, I think that should be a good start.
Okay. And we discussed also, I believe, last week, and I can't remember where we landed on this, but we discussed kind of describing the formula
Mhm.
for how the all the different modes and everything else are kind of combined so that when you actually do give it a name, not the enumeration, but the name of the actual algorithm, that we have hopefully some consistency within said family.
Mhm.
Is that correct?
Yes, that's also my understanding. I think that you have to put it in the guide, and also there we do have in our mapper basically a couple of those naming conventions. Just popped in my mind, but just a general question. We don't have to do that, but is there a benefit in kind of having a kind of schema or regex for algorithm names in the enumeration itself, or do you think it's too complex?
Well, we discussed how there's a lot of outliers,
Mhm.
and I think it's the outliers that's going to kind of throw a wrench into creating a schema, or creating, well, certainly we can create a schema, but we would have to account for every possible type of name. Creating a regex would be just, I honestly don't think so. Both
Mhm.
XML and JSON have kind of a subset of regex that they support. They don't support the
Yeah.
entire thing. And we're probably going to run into limitations. And honestly, I don't necessarily know if all the different parsers actually be able to support the complexity that would actually kind of go into that, or how the
Yeah.
performance of that would be impacted.
So I wasn't thinking about the regex overall. I was more thinking like for a specific algorithm family having a regex, because I think there the pattern is quite, so like for the mode padding.
That would be useful. That would be useful. Where would we put that? So would that be inside that, like the CycloneDX documentation, for example, for like the documentation for that particular enum?
It could be there. I don't know where would be the best place. I mean, the low effort is putting it just also in the guide where we define kind of a low level naming convention. So
Right.
people can copy it out and put it in their tool. We can put it in the schema, or I don't know, in a parsing tool, wherever that's basically think from low complexity to higher complexity or more effort,
Right.
basically.
Right. Maybe that's something we can do. Creating regex makes my eyes bleed. I wonder if that's something we can just throw a chat GPT, and I don't know if it's going to hallucinate or get it wrong or whatever, but I wonder if that's something we can do that. I don't know. Okay.
I think that sounds quite,
that?
that's a good idea, right? So we don't have this explosion of, I mean, we anyway don't want only to have the algorithm families, right? But still give a clear rule how then the actual variant should look like.
Yeah.
Yeah.
Yeah. I like that approach, actually. I think that would work.
We have to come up for every algorithm with a regex. So that's the challenge, right?
That's what I'm saying. Throw that at
That's
chat
for
GPT, because otherwise my eyes
ChatGPT.
are going to bleed.
Or DeepSeek, maybe.
Oh, God. Right. Exactly.
Only for the Chinese algorithms.
Right. Yes. Okay. All right. So where do we want to start capturing this? Do we want to capture this in a Google Doc? Do we want to capture this in Markdown somewhere? How does the group want to kind of proceed with kind of standardizing the list of algorithm names?
For me, both would be fine. I think Markdown is my favorite normally, but I'm also fine with the Google Doc.
Well, I mean, I'm all for simplicity. So if you're fine with Markdown, let's do Markdown.
Nice.
Sounds good, yeah.
Okay. Where do we want to capture this? Let's see. Do we want right now, I guess we don't have to put it anywhere. We can just keep it offline, I guess. We should eventually check it in though. Okay, I'm just sorry, I'm just creating a very, very simple markdown document in Z real quick. And
Perfect.
where'd my Zoom go? And maybe Nicholas, do you have the IBM repo pulled up that you can kind of reference, and I will just kind of take notes?
Yes, I can do that. Yep, I have it here. Should I just go through from top to
Yeah,
bottom?
let's do that.
Okay. So we have ASCON at the top.
What is it?
ASCON, ASCON.
Is that right? Is it all caps?
That's a good question. Wait, the folder is, no, I think it's just a capital letter at the start, and then it's lowercase. Right.
Okay, where is
Yes.
this repo? Can you put that in the chat?
Yes, I can. There we have it.
Great.
I mean, probably it's easiest to do and clone it in a command line and then do an ls and copy all the strings.
Yeah, that would be great. Would that be something that you could do real quick and just share with
Yep.
me?
Yep.
Okay.
Have it.
So otherwise, this is going to take a while.
Yep. No worries.
So, oh, I see.
Yeah.
So, okay. So ASCON, I see. So everything in this model folder, if it has, where'd it go? If it has like derivatives, it has a folder. Otherwise, it just like AES, for example, it's just a single class.
Exactly.
Okay.
Does someone know how to remove the timestamp from the ls command? Because then I can replace basically, or like how to modify only getting the kind of the names.
Just ls.
Yeah, then I have them vertically and not underneath. Yeah, it's just.
I don't know it by heart now.
Okay. I will just quickly search.
Well, everything in here actually has a private static final string called name, which is probably the value that we actually want.
Or already with ASCON, finding a regex is not sure how to do the regex there, because with ASCON, just looking it up, it's an authenticated encryption scheme. So there is ASCON AEAD 128, and there is two hash functions, ASCON hash 256 and ASCON CXOF 128. Yeah, really have to think about the regex, I think, in each algorithm case.
Yeah, it's a good point. Okay, I don't know where I can paste it. Can I just paste it in the chat, or would it destroy the format? Or should I just upload a file?
You put it in the chat real quick.
Okay, I hope it stays as it should. So the folders are basically at the bottom and they are not in the right case. But I
The
can,
folders are not the right case, right? Exactly. Okay.
Yeah.
Got it. So I got the entire list of names then. Where's my Z? Okay, so that makes sense. Okay, so IBM Research has already kind of done the research on all this. All of these have been vetted, right?
Mhm.
Can that assumption be made?
Yes. I mean, for
Yeah,
all
that's right.
those, we have we did some research on the naming, and yeah.
Yep. Okay.
But I'm not 100% sure if the classes are always named corresponding to basically the the right naming. Let's put it that way.
Yeah,
For
so we're gonna have to
example,
go through the directories then, right? Is what you're
I
saying?
mean, no, basically in those Java files, there's a variable called name. This is basically where we definitely define the right name. Because when it's in Java, we wanted to name all the classes with a capital letter. So could be that the standard has a lowercase, so that you wouldn't then see. But I think that's a good first starting point. And the other thing is, for example, for 3-des or triple-des or the CD, however it's called. Yeah, so it could be multiple basically names. I don't know how we want to deal with that. And I mean, it's the same family, but I guess, but there I have not too much knowledge. Maybe Basil, you know how to do that. If or for triple des, I don't know if it's actually the same family as des. So that's,
Yeah, but I think there it makes sense to just list triple des or 3-des.
yeah.
Yeah, because
Yeah.
it's so common, right?
Well, yeah, plus it's,
Or
I
it was
mean,
so
the
common.
algorithm is slightly different, so not any more secure, but
Yeah. I mean, just there
Um,
in the ASCON case, for example, there, I mean, the variants that are now below there, this would be the variants, right? And not the family.
right. The family is
Yeah.
still ASCON, right?
Yes.
Yeah.
And because if we go down this path, then we got to do, you know, SHA-2 256, SHA-2 512, right? All these
Yes.
other variants.
Yes. No, they shouldn't be in there. Sorry, there was a wrong paste basically in the chat.
Okay. Now is OSCON and OSCON hash the same thing? Or are these just, again, variants?
These
So-
these are variants, right? I mean,
Okay.
ASCON is just it's like a family of algorithms for, this is the lightweight cryptography standard.
Okay. I've
And
never heard of
then
it, so I don't know.
And then there are different variants of it. One of it is hash function, right? The hash. Then the XOF
Sure.
is also a hash function or kind of a hash function. And then there are the 128 is.
But they could be like when you look into the algorithm, they could be completely different, just that are part of the same family because they are. So they don't have to share a core kind of library or something. That was actually my understanding, where I wasn't sure in the beginning, but yeah, please correct me if I'm wrong there.
What do you
Well,
mean that it shares the same library or the same construction? Or
Yeah, it does not have to share, even if it has the same name. Like MLChem and MLDSA, they don't share kind of nothing underneath, basically, I would say. Or if I'm wrong there, I don't know. But when I did the research, that was my understanding. Where first it's the assumption that they have to share something if they are of the same library, but of the same algorithm family. But apparently they don't have to.
yeah, but I mean, for those two, I would say they are different families. But I mean, they share some things, like the ML means module lattice. So that's the just the underlying construction, right? Or it's lattice cryptography. They fall both in this family of algorithms, and so that's why they have this common prefix. But I wouldn't otherwise put them in the same family in that case.
But even for Escon, I think there was a case, I think it was Escon, where the 128 is, I don't know, cipher, but the hash is basically a hash, and they don't have anything together. Like, there's nothing they actually share. So at least that's what Hugo did research or told me about one of the families which I kept in my mind. But yeah, if it's not the case, then please correct me.
Yeah, in Ascon, it's a family of algorithms that shares. They have a permutation that is shared across all the algorithms. And then with this Ascon construction, they construct a hash function in one case, and then an authenticated encryption scheme in the other case, and then something else like an extendable output function, which is a more generalized case of a hash function.
Yeah.
But there, I would say it's still the same algorithm family.
Yes.
Ascon.
But but they share something on a much lower level than we kind of.
Yeah.
They don't share anything on the primitive level. Let's put it that way.
Yes. Yeah. While in ML, like MLChem, there's also different variants there, like MLChem 512, 768, and 1024, where they use different kind of parameters of the same algorithm.
Yeah.
Hey, Jade, welcome.
Hello. Thank you.
So what did we decide on that discussion, Basil and Nicholas?
Yes. So I'm wondering. Okay, let me just try to dump my current thinking here. Can be the case that doesn't make sense. But what I see in Escon and also in Blake is that there, even if it's kind of the same family, there could be like different kind of constructs, hash, cipher, or what was the other case? Third remnant function or something like that, or a key liberation function or something. From the point of view of capturing, I think we could still kind of capture an Escon family and have then the specific variant as a name. I'm wondering if that is useful, so if we can derive something from that. Because my assumption was that, okay, if you see in a family like Escon, you know basically what it's about, but you still have to kind of look in the name kind of to understand if it's a hash function or not. I know we have also the primitive section where we can define it. So basically having the ASCII family and then the primitive as hash. So you could kind of combine those to understand which version or variant of ASCII is used here. But
Yeah,
it's the
I mean,
struggle.
yeah, I mean, just wanted to, yeah, because you mentioned the primitives that we have. And I think it would make sense to just take those primitives as a starting point for, I mean, these are the classes of algorithms that we have. And then we can try, or we can try to put all of the algorithm families that we have exactly in one of those groups, right? And
So
then,
if the primitive has changed, then it's a new family. Is that what you're saying?
no, then we have something like one primitive is hash, right? Hash function.
Oh, right.
And then the question is, yeah, how does ASCON fit in there? It doesn't fit because it's different algorithms. One is ASCON hash. So ASCON hash would go into the hash function. So that's one algorithm family. And then we have authenticated encryption, or I think it's called like that, as a family. And there it's ASCON AEAD. I think that's how it's called. That's the algorithm that would go in there. And then we have another primitive is chem, and there, for example, ML chem would go in there, or
so we
Kyber
can,
or Encru.
Yeah,
So
so
we can
ASCII,
just we should always try to put all the algorithm families exactly in one of these primitives.
makes sense, because then we can't put ASCII just as a algorithm family. We have to go deeper and enumerate more.
Yeah.
Okay.
So this would be ASCII hash, and what other ASCII?
There is ASCON hash and ASCON AEAD.
AEAD, all caps.
Yeah. And ASCON XOF. I'm just looking at the ASCON page. So yeah.
Those are the three.
And I think, and ASCII is a block cipher. I think that's just ASCII, isn't it?
Okay, so there is just an ASCII.
I mean, we captured it like that, but could also be.
Right, you captured it. I didn't see if it was like a abstract class or if it's like a concrete.
No, it's always a concrete then
Okay,
instance.
Yeah. All right, yeah, I see that. Okay.
Yeah, maybe I have to review this if it's I think ASCON is just the permutation, just one piece that is part of each of the algorithm. I'm not sure if there is a algorithm itself called ASCON, just ASCON. But I'm not sure.
Yeah, it could be that we just put it in so we can, if in case we detected some ASCII string somewhere, that we could map it to the, like, where we can't distinguish between hash and AD or XOF, that we have still an opportunity to report it. This is permutation. Okay.
Okay, moving on. Blake.
Yes.
I think I have this right, where Blake 2 and Blake 3 are the algorithm families. And then in the case of like Blake 2, there is like derivatives.
Yeah, I would even say
right, but I don't know.
Yeah, when I look at our class, there's this Blake 2x, which is actually an extendable output function. So a different primitive than the Blake 2b, which is a message digest. and the Blake 2S is also a message digest. So I think we have to also split here.
Okay. Yeah.
But Basil, also verify please from the other side. We'll just look also again at the PDF we had here.
Just looking it up.
Perfect.
So Blake 2 comes in, just reading the website, Blake 2 comes in two flavors. Blake 2B is optimized for 64-bit platforms.
Yes.
And Blake 2S is optimized for 8 to 32-bit platforms. And then there is Blake 2BP.
But I think there was also Blake 2X. Let me.
There is Blake 2X. This is a hash function that produces hash values of arbitrary length. So that's a XOF.
Yes,
Yeah.
that's how we captured it. Yes.
And that's also a primitive that we have in the primitive
Exactly.
enumeration.
Yeah, exactly. Back to X, we have an extendable output function, which is this XOF. Yeah.
Then makes sense to have Blake 2X as a algorithm family, I would say.
Yeah. Okay. That makes sense now.
So that means that Blake 2X, and then so like Blake 2B and Blake 2S would then fall into Blake 2 as a family, and then Blake 2 XOF would fall into this, right? Is that what we're saying?
Yeah.
Okay.
Yep.
Okay. We're gonna have to, we will have to go back and revisit and create documentation for each one of these enum values too. So okay, cast.
That should be simple. I don't know why we have there a separate.
Yeah, you've got a 128 and 256 value.
Yeah, it's basically block cipher like IS.
Right.
So I understood. Yeah. So I think cast is here or case is here fine as a family.
Elephants, I find interesting. Delirium, Dumbo, Jumbo. This is funny. Somebody had fun in their PhD.
I think those.
Elephant is an authenticated encryption scheme.
Yes.
And
so nice that you validate the model now. Yeah, we have Jumbo is also authenticated encryption as it seems, but it has also a separate name like elephant sponge minus pi 176.
Yeah, so like this Delirium, Dumbo, and Jumbo,
Mm-hmm.
are these individual families then? Because they can have derivatives?
I think for me it looks like that are just different variants, but in this case they gave those variants names and not a kind of
Okay.
a pattern. That's how it looks to me and why we captured it that way. Because from the code, what I see is that we still inherit from elephant, but we set different block sizes and tag lengths as default values.
Looking
I
at their paper, I mean, looks like it has elephant is the family, right? And then it comes with different hash functions, basically. One's ketchup, one's spongent,
Okay.
and then numbers of what is this? The number ketchup has a permutation, I think. And then it's a number of times this is done.
Okay. Ghost also has what seems to be a lot of variance.
Yeah. Looks like that. Yeah. I think here we can also keep the ghost family. I don't know. I mean, there are not all. So some of them are signatures, some of them are block ciphers, authenticated encryption, message digest. I don't know. Because then we have to enumerate basically all of those. Well, because there's no pattern, they are basically named by date, it seems like, or time.
Right.
Most. Yeah. Or we go back, because I mean, or we go back to, yeah, I don't know. Go back to having just the simple name, like the underlying, like Asken and Blake and Ghost. But I mean, I like the distinction between algorithm and primitive, but I feel also it gets quite complex now. And if we do the same now for Ghost, we basically enumerate all of those.
Right.
But I'm not sure. Would be. What are your opinions?
Yeah, with Ghost, Ghost is really like a collection of different algorithms, right? These are the Russian algorithms, basically.
Right.
And then there are really different things in there that are kind of unrelated. I think there is a elliptic curve signature scheme, and then there is hash
Wow.
function, encryption, so
Mhm.
all kind of things, and they all are under this Ghost term.
Yeah.
So does that mean we need to enumerate all of them then?
If we want to.
Because they're so
Hmm.
different?
Yeah.
Yeah, maybe just there's one circle here or one other turn in to also. What do we think an algorithm family? How we interpret that? How we define it? Does it basically related to the naming, or as we now do it, basically related to the actual crypto? I think it solves different use cases. The crypto related one is more precise and allows distinction there, but could be that in some cases already the term ghost is enough that you know it's basically a Russian algorithm and you don't want to use it. But I'm not 100% sure. I think going more precise would allow more use cases, but would take more time here and a longer enumeration. And when we define algorithm families based on primitives, that then would be then the result. But we could also define it based on basic naming. I don't know if that makes sense, but just, yeah.
I
Yeah, I
think
mean,
we-
you have.
Go ahead.
Not just thinking. I mean, you have. I mean, these are the names that are in the tooling, right? In the CBOM tooling. And in this case, it's not going into detail, right, about what kind of ghost it is specifically. So yeah, you think that's usually sufficient for from the tooling perspective, or would it be useful to go into more detail there?
Well, if we have descriptions and as we talked about having maybe a regex for the family, so you know how the pattern is, the regex for this wouldn't necessarily be a pattern. It would be the 6 or so actual variants that exist in that family. So from a tooling perspective, I think that would be fine. What we need to do, and I don't know the answer how we do this, but I think we need to kind of strike a balance between something that's going to be useful and automatable and something that is not going to require us to have just a really big burden on maintenance of this enumerated list. I don't know what that balance is, and I'm gonna look for guidance from both of you on figuring that out.
Yeah, that's exactly the point. I agree.
Yeah, maybe we could also be a bit like pragmatic and think, okay, these are some commonly used algorithms there. We could actually list them a bit more in detail. For example, like with ML, right? So it makes sense to have ML DSA and ML Chem differently, while for others that are a bit more exotic, just keeping the family high level term might be enough. And then, yes, as you said, Steve, right? I mean, if we want to do a regex for each of them, we might also end up actually doing an enumeration of all the variants again.
Right.
Also have to find a balance there. I mean, for some of them, it's easier, right? With the like AES, there we have different modes, right? 10 different modes, maybe. That's one part of the regex, and then the key size, that's another part of the regex, and the padding, that's another part. But then for Ghost, they just have different numbers or acronyms.
Yeah, for AES, I mean, there's probably, I'm just guessing here, but like 100 different things if we kind of enumerated them all.
Yeah.
Right. Which we don't want to do.
Yeah. But I mean, if we go that route, if we assign basically a primitive to like a different primitive is different algorithm family, then we have, for example, every IS with GCM mode also in a different family, because this would then turn it into an authenticated encryption.
Right.
If I'm correct. So
yeah. So what we're saying here, again, is we're not going to have consistency on the criteria on what constitutes a family and what does not. Fantastic.
Yes. Good result of that call, I guess. Yeah.
Okay.
Yeah, but it's good to see some where the difficulties are, right? Then in practice.
Yeah.
I mean, also in identifying these algorithms at the end.
Yeah.
From a tooling perspective, if you had Ghost and then if you had a regex of the different values that constitute, hey, these are the things that you can find from a tooling perspective, would that be acceptable?
I mean, yes, from a tooling perspective, yes. The question is just if we want to have some consistency or where we put the line in maintaining and usability. It seems like if we do it for a lot of algorithms, it will be a lot of work, because I think also our enumeration of ghost algorithms is not complete. So I think we missed also some.
Okay, so there's some other ones that we don't know about.
Yeah, so maybe as a yeah, statement, these algorithms we captured there are basically the ones we found in the bouncy castle and JCA and Python library where we try to so basically what they enabled, that's what you find in the model. So if there are others that were not supported by those three libraries, we currently don't have them.
Okay, got it. That makes sense. Now, Ghost also has this thing called Crypto Pro. It's pro, so it must be
Yes.
good, right?
Yes, exactly.
What is
Yeah.
Crypto Pro? What is this part of Ghost? Is it not part of Ghost? I don't know.
So we added a link there, and it's a link to some IETF standard RFC 4357. And when I just read what we linked here, it says this algorithm encrypts Ghost 281447-89 CEK with a Ghost keg.
Yeah,
It can be used with, so it's basically a combination of two Ghost algorithms that they named Crypto Pro.
I see.
So new name, I guess. They wanted to do something different this time.
Yeah, what we're finding is that a lot of these RFCs from Russia are basically informational RFCs as well. Just FYI, because there's
Okay.
a different, there's yeah, because the what that their hashing algorithm, Steerbog or whatever it's called. We added that, and well, we're adding that I think in 1.7. It passed already. That was
Oh.
also an informational RFC.
Okay. Nice.
Okay, so does that mean well, I mean, Crypto Pro then is just a way to use existing Ghost algorithms in a new way, right? So does that warrant a new family? Does that meet the criteria or not?
Yeah, good question. I mean, I would say then triple des shouldn't be.
I was thinking the same thing.
Yeah.
Triple des is so widely used.
I know. It's that's where I have my problems with the consistency of this whole environment area.
I love the lack of consistency here.
Yes.
Okay.
Yeah, maybe we
well,
have to think a bit again about the methodology, right? What to use, right? If it you really want to have needs to be able to assign them to uniquely to a primitive, right, or not.
Yeah.
And what level
Yeah.
of detail to choose. And if it should be consistent or if it's okay if it's not consistent.
Yeah.
Yes. Yeah. I still wondering, speaking from the use case perspective, what is something in the algorithm family property that is helpful? And I struggle to find there the sweet spot of usefulness.
What is, I'm sorry, go back, rewind.
So we look at the algorithm family property in the future CBOM and imagine thinking now about what value would be useful for which use case. And
Right.
one thing, there could be just ghost in there. Then I would probably say one use case would be saying it's a Russian algorithm, I don't want to use it, or does not comply with my regulations. But it wouldn't tell me maybe what type it is, so the primitive. So if that is, now I could think I will combine the primitive property with the family property. So if there's ghost and hash, I might be able to solve my use case even without knowing the exact algorithm. Probably enough. But I'm not 100% sure.
Yeah. I know we're at time. What I'm going to do is I'm going to take this list and create a JSON enumeration of it with the documentation and whatnot. That way, the next time we meet, we can kind of continue this conversation, but we can also go back and start filling in some of the documentation, maybe even work on some of the regex or whatever we end up doing there as well. So does that sound good?
Yeah, sounds good to me.
Okay. And then is there
Thanks.
anything that we need to review next week for the PR that you submitted, Nicholas?
I just added 2 weeks ago the certificate extension. It should be fine as discussed, but if you want,
Yeah.
you can have a look.
Okay.
Yeah, but nothing else.
All right. Very good.
Sorry, just one quick question, since this is the first meeting I've attended half of. What regex are you working on? Can you just give a,
What's up?
what regex are you working on? Like, what are you trying to do with regex?
One possibility of using regex is to, if we have algorithm families, we don't want to enumerate every single variant that exists. So one way that we can not have to do that, and right, we got 134 algorithms right here. If we listed every single variant, we might end up with a list of 1,000, for example, which we, again, don't want to do. One solution to that could be using regex to express how the standard, for example, AES, has come up with a way to name AES and all the variants. So that when you are looking, like from a programmatic perspective, if you're looking at source code, for example, like the regular expression that that particular standard uses to express all the different variances of names that might exist.
Okay, all right, thanks.
Yeah. Good question. I think I captured that, right? Is that correct, Nicholas?
Yes.
All right. Thank you for joining. I thought this was pretty productive, so thank you. I will let the group know in the Slack channel once I have this checked in and we can kind of review it. But yeah, it'll be ready by the next time we meet. So with that, have a great rest of your day, and I'll talk to you soon.
Thank you. Have a great day.
Yeah,
Bye-bye.
bye.
Cheers.
All right, bye-bye.